Imagine extending the VT system's functionality with custom test functions based on user FPGAs. No complex FPGA workflows required. Sounds good? Then stick around. Hello, I'm Sandro Kuhr, firmware developer at Vector in the VT System division. In this video, I show you how easily you can manage your user FPGA projects, compile them and deploy them onto a VT module using the FPGA Manager. So, what is a user FPGA? We offer some VT modules like this VT2848 with an optional user FPGA on top. You can fully configure this additional chip yourself. That means you can run your test functions right on the hardware, super fast, very direct, and with immediate access to everything the module offers. Enough theory, let's look at an example. What we have here is a notebook running CANoe, a VT system with the digital I/O module we just looked at, and an LED. The goal is simple. We want the LED to blink and we want to control it through system variables. The blinking itself is handled directly in the user FPGA code. To demonstrate how we get there, I take you through the whole workflow. I'll show how to work with the FPGA Manager, how to compile the code and deploy it onto the module, and how to exchange data with CANoe. Let's start with the FPGA Manager. First, we click on the Workbench folder and choose New Project. Then we pick the module type we need and give the project a name. Next, we select Single Module Project as a project type. After that, we set the target module. In our case, it's the VT2848. And finally, we choose the workflow, Simulink, Simscape or HDL code. For this demo, we're using HDL code. In our project, we want to make an LED blink. The LED should be activated by a system variable in CANoe, and its status should then be fed back to CANoe via a different system variable. To do this, we need to create two system variables in the FPGA Manager. First one, enable. This is the control value transmitted from CANoe to the FPGA. Second one, LED status. This is the feedback signal transmitted from the FPGA back to CANoe. The direction tells you whether the system variable is an output, for example sent from CANoe to the module, or whether it's an input sent from the module to CANoe. Now there are a few general project settings that need to be made. The FPGA clock frequency defines the speed at which the FPGA will operate, while the input variable cycle time defines how quickly the system variables are updated from the user FPGA to CANoe. That's it for the settings in the FPGA Manager. Now let's open the main source file using the Edit button. You can use any editor you like. In my case, it's Notepad++. In the entity of the VHDL file, we see the two familiar system variables, enable and LED status. The channel index is 0 because it was not assigned to any channel in the FPGA Manager system variable dialog box. In addition, all input and outputs of the VT module are defined in the entity. In our case, with VT2848, there are 48 input and output signals. We use output 1 to control our LED. I already prepared a piece of code to paste here for this example. The code contains a blink process. Enable will activate the blinking and status signal will report back the LED status. Now let's go back to the FPGA Manager. When we click the Compile button, the tool automatically generates the VHDL code for the user FPGA and saves it in the project folder. After this step, the FPGA Manager compiles the project and deploys it onto the FPGA. So far so good. Now let's switch over to CANoe. In the VT hardware dialog, we scan the connected modules and then activate the system variables we need. In the data window, we add the system variables that we obtained through the module. These are also displayed in a panel. Now let's start a measurement in CANoe. When we activate Enable in CANoe, the LED starts blinking, here in the window and of course on the hardware itself. This proves that we can exchange data with our user FPGA and that our VHDL code is working. Now it's your turn. User FPGAs in the VT system offer powerful capabilities, high-speed signal processing, complex simulation and the implementation of custom protocols, all directly on the hardware. Thanks to the VT FPGA Manager, this workflow is easy, intuitive and efficient. Find out more and explore detailed resources on our website. Make sure you don't miss any news about user-programmable FPGAs in HIL testing. Subscribe to our Vector Tech tutorial channel and turn on notifications for more exciting insights and practical tips. We look forward to your projects and feedback. Thanks for watching and stay curious.